There you are.
That'll sit there for about half the time I'm talking. So as I talk, you'll have to envisage things happening before I then show photographs of what actually did happen. So my direct involvement with the egg electrification project started when I was elected a director of the Isle of Egg Heritage Trust. I became one of the island trustees. As John said, there are 4 of them, and you are elected by the Residents Association, and you serve a 4-year term. My initial operations were a responsibility for housing and the development of housing, for continuing education, and for entertainment, fun. So I think probably when I was appointed to be the project director for the electrification, I was at least able, as a compensation, to pass off fun to somebody else. But prior to becoming a director, I'd taken part in the discussions at the Residents Association meetings where we discussed the type of scheme that we hoped we might be able to have. The preferred concept at the time I was elected director, which was in 2005, was for an all-island grid powered by the renewable resources of wind, water and possibly solar power, based on an outline costed design produced for the island in 2004 by a company, eConnect, now Synergy eConnect, now I think Synergy, of whom Ruth Kemsley there was very much involved in the project as one of the contractors. And I hope, with Ruth's permission, that if technical questions are asked, I can involve Ruth in that, because she knows, if anything, more than me about that part of the project. The main source of hydroelectric power, was to be the Burn Above Lag Farm there. And we were going to build into the scheme 2 other small hydros that were pre-existing. One of them was at Kildonan Farm, and the other one was at the edge of the bay near the pier. The wind farm had a preferred site. The residents preferred a site to the south of the island, just in the region where it says Galmersdale there, and there was no particular site selected for any PVs that we might have. The estimated cost of the scheme, including the design element at that time, was 1.34 million, and it offered 13 kilowatts of hydroelectric power at Lag, and 6 each at the pier and at Kildonan, 75 kilowatts of wind power, and possibly up to 30 kilowatts of solar power. So a total renewable capacity of 130 kilowatts with generator backup. All cabling was to be laid underground to minimise the impact upon the beauty of the island. Funding was sought by our then project officer, Ian Lever, and by the autumn of 2005, the necessary funding was approved, and immediately following my election to the Trust, which is where John's story comes in, it became the responsibility of the directors to decide if we could go ahead with the project, and if so, obviously, to assume responsibility for making it all happen. And the meeting was one of the meetings that we had at Fort William of the full board, at which this was decided, and the meeting at which I, who knows, perhaps foolishly, offered my services as project director. It has to be said, nobody said we don't want him as project director. I think everybody was rather relieved, you know, that somebody daft enough had come forward to do it. So our discussions of the project at that time, and I'm sort of telling you this as a history, really as an account of what we did and why I think we made our project work and why it was so involving of the community. So it's just the story of what we did and in a sense why we did it. Our discussions of the project at the time raised 4 key questions that we really had to answer before we could actually set the project in motion. I mean, it's all very well to say, we'd like to do it, we think we can, but you've got to know you can. Firstly, obviously, would we be able to afford to build it? Well, the costed proposal assumed construction during 2005 to 6, and no allowance was made for inflation or other cost increases beyond that. But our building programme couldn't really be earlier than 2007. And further, the funding offers that were available at the time were for the whole project, which meant that if, for example, the design phase didn't produce a workable budget for the construction phase, the trust would be left liable for the cost of the failed design phase. And additionally, we had no contingency to allow for cost increases during construction. So we set a number of checkpoints which, if not achieved, would bring the project to an end and with minimum loss to the trust. So the first one was to obtain funding for the design phase as a separate entity, so that if we couldn't get a budget and we had to stop the project at that point, if we simply couldn't build it within the money we'd got, the trust would not lose large sums of money by having to terminate the design phase. Secondly, achieve a budget for the construction phase within funding. And thirdly, build contingency into the construction phase costs. Secondly, would we be able to afford to run, maintain and repair the system once it was in place? Our aim was to maintain the system ourselves, because this is the sort of thing we do on EGG, and I was asked to calculate the cost of running it on that basis. We'd had costings done in part by the eConnect scheme, and also the project officer had done it. But I was asked to redo it, and this actually is not an easy project because it's based entirely on best estimates, because such a scheme hadn't been built before, and so it's difficult to predict how it might perform. However, the rate we set at the start was actually about right, so we were fortunate in that respect. And then thirdly, did we have sufficient skills at our command to bring the project to fruition? We decided that we would contribute as much as possible ourselves to the design and construction of the system in the interest of economy, accountability and maintaining overall control. There were good relevant skills and knowledge within the community, and we determined to make as much use of these as possible. Nonetheless, we recognised that there were many special skills required for which we would need a professional project manager, all like drawing up contracts and so on for the tendering process. Fourthly, would the proposed system be of sufficient capacity for our needs now and in the foreseeable future? Well, based on the figures shown in the proposal by eConnect and on our own measures of electricity consumption by a number of residents and businesses on the island that we monitored over a period, we could see that the scheme would produce enough power on average for our averaged out requirements month by month. However, we recognised that the scheme was of limited capacity, and to minimise the possibility of overload, it was at that point that we proposed the cap. 5 kilowatt cap for domestic properties and holiday properties of a domestic ilk, and 10 kilowatts for larger businesses. And as we do on EGG, EGG Electric having come to this conclusion that it needed to do this, we put the proposal and defend it to the Residents Association. The residents vote on it, and it's on the basis of their vote whether that happens. And they voted unanimously in favour of the capping. And on this basis, having satisfied these 4 questions, we decided to go ahead with the project. Synergy Scotland, similar name to Synergy eConnect, but Synergy Scotland, based at the time in Inverness, was appointed to manage a tender process to select a design and build contractor, and I was appointed at this time to represent the trust as project director, with the brief that where necessary I could take decisions without prior reference to my colleague directors. Actually, that brief sensibly soon became the norm. It becomes the norm because, you know, you take a decision and then the next time they say, oh, you're used to taking these decisions, you know. Actually, it was useful because my close proximity to the project gave me the best knowledge of where we were and how everything was to work. And so it put me in the best position, really, to take informed decisions. It also enabled me to build up a relationship of confidence with the project manager and the contractors and subcontractors. And I'm really grateful to my colleagues at the time for giving me this trust and confidence. It actually made the project much easier to operate. Egg Electric, a wholly owned subsidiary of the Trust, as John has described, was set up as the body to own and run the scheme. And from this point now until the appointment of our main contractor, which was Scottish Hydro Contracting, a number of technical and financial issues were addressed, including separating the funding for the design phase and the construction phase, and increasing the grant level in some of the funding applications. One of our funders was happy that we should use them to pay for the design phase. The final funding for the project at this point was set at 1.629 million. The design phase was initiated, and it was agreed that all parties would work together with completely open access. So it meant that the contractor knew from day one exactly how much money we'd got. And we knew all the time exactly how much everything was costing, including their profit margin on it. So everything was open. We all had open access to all of the paperwork. So it meant that everybody who represent, myself representing the island, different people representing the contractors and subcontractors, all had completely open access to all the information, and we made it available to the funders as well, so that they knew where we were and what we were doing. This actually was very helpful almost immediately, because the first problem to resolve was the core energy resource. In the proposal, it was wind power was the major, 75 kilowatts was the major resource, but the machines upon which this was based just at that time were withdrawn from the market with technical problems. In fact, technical problems that were never resolved. And the Scottish Hydro tender contained an allowance for a greater capacity hydroelectric generator than that offered in the eConnect proposal. And I went out with the contractor's consulting engineer to survey the burn above lag. And it became apparent that it would indeed support a much larger hydro than that envisaged by changing the location of the machine and the point of water collection for it. And so 100 kilowatt hydro was proposed on the basis of measurements we took on the day that we went out. And making a fundamental change to the scheme from primarily wind-based to primarily water-based was an easy decision to take, because overall the cost per kilowatt capacity installed was less at the time for hydro generation than for wind. And also hydroelectric generators, kind of being there and sitting on the ground in front of you, and being a very established technology, I would suggest greater mechanical reliability, greater durability, and certainly much simpler, safer, easier servicing. So it really offered all advantages, and I think probably it was the best decision to make, as you'll see when I describe later in brief how we control the system. To remain within budget, we reduced the capacity of the proposed wind farm and of the PV panels, but the first budget that we got from the system came in at well over what we could afford. One major contributing factor being the cost of the distribution network, which was bigger than had been assessed in the proposal, mainly because the proposal couldn't take account of the undulating ground, the rocky areas, and also the fact that there were a lot more properties wanting to join than had originally been envisaged. And there was also one of these things, there was a big hike in copper prices at the time. There was one of these copper shortages that put the price up. So this was the major problem that we had. And the first budget came in something like 300,000 over budget. So the next 6 months were spent working this down, because we'd set the checkpoint. If we couldn't get a budget, end of project. So because of our close contact with the project at all stages, we were able to contribute to the design phase and then later to the construction phase in many ways that helped to reduce the budget, because people from Egg were acting voluntarily, so if we took something out of the project, it cost nothing for us to do it, so it saved money. So we negotiated with Scottish Natural Heritage for agreement to locate the weir and pipeline for the hydro in an area that was designated as a triple SI, Site of Special Scientific Interest. And we negotiated with SNH for agreement to construct a service road to the weir and to the pipeline through the triple SI. We surveyed and marked out the track of the road for the approval of the contractors and for SNH. We obtained the SEPA licence for extracting water for the hydros. We proposed, surveyed and set out many of the cable routes with the advantage of our knowledge of the topography of the island. We negotiated all permissions and way leaves for the laying of cables. Even though we laid cables under trust-owned land as much as possible, there were still 14 way leaves to negotiate. Some took a long time. We carried out a road survey for the council department and obtained all the permissions from the council for cables where necessary to pass in the road corridor and under the road. We arranged the archaeological survey of the pipeline, cable routes and sites for the renewables and buildings, made the planning application for the wind farm, and made proposals like replacing the concrete block building in the design for the control building with an agricultural shed. All of these things that we could do ourselves, that we could take out of the project, that had a considerable monetary value when charged for by the contractor. And so these all helped to get the budget down and to build a degree of contingency into the construction phase. The construction phase took just over 12 months, and one way or another involved almost the whole community in its successful outcome. As example, our construction company, Egg Construction, successfully tendered to erect and finish the main control building, the building for the hydro, and the bases for all the transformers. We handled all incoming materials from delivery to the pier to site. That was all the materials, concrete materials, steel work, inverters, batteries, the lot. We did all the handling on the island. We marked out all the cable routes ahead of the civil engineering subcontractor and made changes as necessary to avoid rocky areas, and which involved additional permissions and way leaves. And we also organised the inspection of the wiring of all properties on the island, and 3 of us as volunteers rectified all the errors identified by an inspecting electrician that I hired in to report to us from our contractor. I said that takes a couple of sentences. All properties were brought into full conformity with the latest IE regulations, and that took the 3 of us 4 months, solid, to do that. Some of the wiring on the island, as you can imagine, in a place that's never been connected to anything except by the people themselves, to generators and so on, caused much merriment to the inspecting electrician. He kept saying, "Oh, I wish I brought my camera. The boys at the depot would enjoy this." And some of them are almost like something from a Frankenstein film, big switches like, in Dr. Death's House of Horrors for turning things on and off. And an electric light in one of the house. It was a standard lamp. And we were in there and inspecting the wiring. It was getting dark, so he turned it on. He got a stick and poked it, and it came on. And I said, "Why did you do that?" He said, "Because if you touch it, you get a shock." Anyway, during all this, it was really quite a fraught time trying to contain the budget because of limited contingency. And in the end, we did actually go over by 3%. So compared with the Scottish Parliament, not bad. 3%, but it looked as though we were going to end up with just one windmill. But fortunately, at our 10th anniversary celebrations on the island, Ian and I were able to speak to one of the funders, and the Scottish Energy Minister involved himself in this, and we were able to make a pitch to him as to what we'd done and why it was important to have the wind generators, and they were able to fund us, so we got the extra funding for the wind generators. Now the project started generating power, then we're going to get some more slides in a moment, on the 1st of February 2008. At first we'd just had the hydro and the PVs, the main hydro and the PVs, and just a few houses connected. The first opening part of the process was really just to check stability. So, and then gradually we added in more houses and more renewables, and it really was October before everything was fully connected up. We did a lot of modification work to stabilise it, much of it done by Egg Electric themselves, because the contractors handed the project over to us in June and came back making extra connections as we engaged them to do this. So not all the houses were connected by then, but they were by October. So when I show slides of performance, they all start from November onwards. Anyway, so what we had at that time was the lag hydro, which was, having pressed that and it not moved on.
Just click the mouse button once.
Click the mouse button once. Not that, that one. No?
Yeah.
There you go.
Ah, there we are. And then, yeah, right. The lag hydro, which is a 100 kilowatt machine by Jilks. It's a Turgo, which is based on a Pelton wheel type machine. The wind farm, I'll go through all of this in non-technical detail, then anybody who wants to know anything technical will be very happy afterwards. Wind farm, the 4 windmills of 6 kilowatts each and the little control building for it. A PV array that at the time, and that's the picture of it, of 9.9 kilowatts capacity. Now the power generated by each of the renewables was fed into the island grid, and the picture here shows where the different renewables are located: hydro, wind farm. The PV panels are here. It also shows the location of the transformers, because it's a high voltage grid running up the island. Well, high voltage in our terms, not in industry terms, 3,300 volts. So transformers at intervals to transform the power down to feed the houses, and the transformers are at different capacities depending on the work they have to do. Now, the major problem of producing consistent power from renewable resources is that their output is widely and rapidly variable, depending as it does on the vagaries of wind, rain and sunshine. And to ensure steady 24-hour power, the system is backed up with a bank of batteries, 96 of them, total capacity 518 kilowatt hours. And these are directly connected to the grid via inverters. There are 12 of those inverters, and they're actually set out in 4 groups of 3, it being a 3-phase grid. They're programmed together, the groups of 3, to produce true 3-phase power. And in fact, it's the battery inverter system that sets the baseline voltage and frequency of the system, to which everything then synchronises. The whole system is backed up by generators, and there's 2 of them, one on standby, one in reserve. The system works essentially, as I say, the renewables all feed into the grid, and everybody derives power from the grid. The batteries inverter system, besides providing the baseline voltage and frequency of the grid, and also smoothing the power so that we have consistent power always available. They work in the way that if there are insufficient power coming from being provided by the renewables to provide the island, then power flows out of the batteries to make up the deficit. If there's a surplus of power being produced by the renewables, then power flows into the batteries. Surplus power to requirement flows into the batteries. Obviously, these processes can't go on forever either way. In the case of if there is a deficiency of power generated by the renewables for a sufficient period, then the batteries tend to discharge. Once they discharge to a level selected by ourselves, which is 60% capacity, then a signal from one of the inverters is sent out to the generator to come on. Generator comes on. We have a synchronizing process that allows the generator to run while the other renewables are still operating, particularly the hydro, and then it assists in charging the battery and running the island. At the other end of the scale, if the renewables are in surplus, then the batteries become charged. Once the batteries become charged and you're still energizing the system, then the frequency must rise. Once the batteries are fully charged, the frequency of the system must rise, and we use the rise in frequency to control the system. Mostly we have surplus power in the winter, so we actually have a number of heaters in community facilities, community hall, down at the pier, in the churches, that are, these heaters have frequency switches attached to them, and as the frequency rises above 50 hertz, first at 50.1, then at 50.4, then at 50.7, these heaters come on. And mostly this will balance the system. You know, we've got 36 kilowatt capacity of heaters, and so, you know, you're running the island on the renewables. So most of the time, these heaters, in their fluctuating on and off, will balance the island. But if not, and the frequency continues to rise, we take advantage of the properties of the inverters, firstly attached to the PVs, which connect the PVs to the grid, and the wind farm to the grid. And as the frequency rises, these become progressively less able to interact with the grid, and so it backs the two renewables off. And again, technically I can it's all right, I'm within hand. So we can do that, and then finally we adjust the frequency setting at the hydro so that the frequency can't rise above 51.8 hertz. Now, why did we choose 3 resources? Well, we don't have enough power provision by any of the resources on the island to generate everything we need. Not enough hydropower, not enough turbulence-free locations for a wind farm, and not enough ideal situations to plant PVs. But then the PVs are of benefit in the summer. So that really was the rationale. The other rationale is that most of the time the hydro provides us with most of the power. The complement through most of the year is the wind farm, but in the summer months, May, June, July, August, is when the PVs come into their own. And so while we had 9.9 kilowatts at first, we've upped this by 20 kilowatts in 2011 and another 20 kilowatts this year. And I've got 1 minute. I'm just saying that if I summarise it, overall, we get about 85% of our power from the renewables, and that's just a chart that shows the total consumption month by month of the island. The green bit is the renewables, the red bit is done by the generator. You can see the effect if you look from 2010 to 2011. Between 2010 and 11, we added another 20 kilowatts worth of PVs. And you can see that, you know, if you take 2011 and 12, which was a bit of a wetter year, but nonetheless, that you can see the effect that the PVs have had. You can't yet see the effect that the new PVs that we had this year have had, because they weren't commissioned until July, so we won't see any benefit until next year. So thank you, anyway.